I'm playing my game right now, and I know it's probably hard to see in the video, but one thing um, that you might notice, or at least if you're playing it yourself, is that the controls work like perfectly. So the instant I push a key, I'm moving full speed in that direction, and the instant I let go, I come to a complete stop. And what I'd like to do is maybe introduce some sloppy physics where we have some acceleration and deceleration, and things kind of slide around a little bit, and maybe a friction component to the game. I think in general that might make it just a little bit more fun to play. So let's get into the code and look at a few ways to accomplish that. So I'm going to go to my player class, and we've got this function, go left, go right, and then we've got the stop and the go up and down, and then the stop vertically functions. And just for comparison, rather than just replace this code, I'm going to comment that out. And what I'm going to do is when I go left, so instead of immediately setting the velocity to the speed, in this case in the negative direction, I'm just going to slowly up the velocity in the negative direction until it reaches the maximum speed. So I'm going to say self.vx, and I'm just going to say minus equals 0. And I'll just do 0.25. Okay. Um, this is definitely a number that we can play with. And so then we want to cap it. Actually, we'll run this and watch what happens when we go left. Okay, so I'm going to control the blue guy here. We'll give myself a running start here, and we'll move to the left. And you can watch it starts to accelerate. Do that one more time. So instead of just instantly going up to speed, it accelerates, and it's going pretty quick by the time it hits the edge of the screen. But if we have a really big screen, maybe we don't want to accelerate forever, because this could get going very, very fast, especially if this is a higher value. So I still want to cap this at whatever the max speed is going to be. So I'm just going to say itself.vx is less than -1 times self.speed. So this is now the max speed that the player can go. I'll just say self.vx equals -1 times self.speed. All right, so this is essentially, we're just limiting the speed. And so now when I run this, just confirm that it works. Go up, and I start going this way. And I did accelerate. It's probably hard to see it. Yeah, you can see the acceleration happen right here, but now I'm topped out at whatever my max speed is. All right, and so I'm just going to copy this, and if we're going to the right, everything is exactly the same, except we're going to do a plus, and we're no longer negative, so I can get rid of that. Okay. And so I'll check that this works in both directions. Okay, and go this way, and did I? This should be a greater than now. All right, I allowed myself to accelerate. So let's confirm, and we accelerate this way, and then we turn around and we accelerate that way. So that looks pretty good. Now for the stopping, right? Currently, when I play my game, or when I let go of the key, again, this is one of those difficult things to see in a video. But as soon I accelerate, but as soon as I let go, my stopping is instantaneous. And so I'd kind of like to slide to a stop as well. And so right here, I'm going to go to my stop horizontal function. Whoops. And actually, I can get rid of this now. And rather than just set the velocity to 0, what I want to do is slowly have my velocity approach 0. So in this case, I need to think about what direction my player is moving, so I know which way to change in which direction to change the velocity. So let's start out with if my player is moving to the left. So self.vx is less than 0. All right. If you have a negative velocity, you're moving to the left. I just want to take my velocity, and I'm going to add to it, and I'm just going to add this exact same amount. And if I'm moving to the right, so my velocity is greater than 0, well, then I'll just subtract from it to slow down. And so with a minus equals 0.25. And let's see what happens. Oops. Hit the dot. And then you can see when I move to the left and I let go, I kind of, hopefully you can see it in the video, I kind of skid to a stop. So I accelerate, let go, skid to a stop, but I can accelerate in either direction and skid to a stop. So this is good. Seems to work pretty well. This number right here is something that you can just tinker with until the game feels right to you. And then, we can basically follow the exact same pattern to get the go up and go down and stop vertical to work. But before I do that, before I go into the go up, down, and vertical, I want to show what happens when you change this number, because depending on the number, you might get some kind of weird effects. So I'm going to change this to 0.1. So we're going to have a little bit slower acceleration and deceleration. And I guess we'll call this like the friction component. Did I get it everywhere? Yeah. And so I'm going to start here. And again, I can move up and down, without any friction at this point. I haven't done that. But I'm going to push to the left, and you can see I skid to a stop, and I'm going to push to the right. And okay, I'll do that again. I'm going to push to the right, and I'm letting go of the key right now. And then something interesting has happened. Okay, rather than skid to a stop, my player just reversed direction. I'm not pushing anything on the keyboard right now, and I'm sliding the wrong way. So it's kind of weird, because mathematically, it doesn't feel like that should happen, right? If you repeat, so let's say we're going to the right, if you repeatedly add 0.1 to a number, right, you'll accelerate, but my deceleration should be subtracting 0.1, and eventually I should land back on 0. And so so I should stop subtracting 0.1 when I decelerate, once I actually land back on 0 again. And so something weird happened here. So I'm going to open up a shell just so you can see. And so right here, I'm just going to go ahead and do a little math. I'm going to do 0.1 plus 0.1 plus 0.1. And look at the result here. And you would expect, I think, that the answer would be 0.3 exactly. But we got something different. And so this is going to give us some insight into what happened with our game. And this seems weird. It's like, well, why can't the computer do this? Because when we do 0.25, 25 plus 0.25 plus 0.25, the computer gets the exact correct answer. So why can it do this problem perfectly, but it can't do this one? And so let's just think about how we represent numbers in our normal decimal system. If I wanted to represent a number like 0.25 as a fraction, well, we all know that 1/4 is a way of representing it. All right, so we can go back and forth between these two things exactly. But if we were in the decimal system and I wanted you to represent something like 1/3 as a decimal, right, you could write, if you say 0.3 or 0.33 or a bunch of threes, but we should understand that this side of the equation and this side of the equation aren't exactly equal. In fact, this is 0.33, no matter how many threes I write, is actually just slightly less than this. So if I wanted to write a fraction like 1/3 as a decimal, eventually I have to round or just truncate the decimal or something like that, and I lose just a little bit of precision. And so in a system like, in something like the decimal system, right? I can represent a number like 0.25 exactly as a fraction, or I can represent a fraction like 1/4 exactly as a decimal. But something like 1/3 or 2/3, right, I can't. So I can go 0.66666, and I either have to at some point decide to round up to a 7 or maybe just, write a whole bunch of 0.6s, but I can't represent certain fractions exactly. And a computer has a similar problem. Okay, it turns out because computers store things in binary to a fixed number of ones and zeros, binary digits, a computer can store a number that is a fraction that's a power of 2, like 1/4 or 1/2 or 1/8 exactly, and do perfect arithmetic. But something like a tenth, right? Like, in the decimal system, we can do a tenth and we can say, oh, it's 0.1. Well, when a computer tries to represent 1/10 in its memory, it can't, because it's storing things in binary. So this is one of, in decimal, this works fine, but in binary, the computer has difficulty with this, and the fraction 1/10 is going to get rounded slightly once it's stored in the computer's memory. So there's a little bit of imprecision. So what's happening in our game when we go? When I move to the left, and I'll move to the right, and I'm going to let go, and my little block starts reversing. What's happening? Whoops. What's happening is if you accelerate, you go 0.1 plus 0.1 plus 0.1, my speed gets to here, and so I'm not 0.3, and I subtract 0.1 as I decelerate, and I'll take this number, and I'll subtract 0.1 again, and you can see I'm not at 0.1, and I'll take this number, and I'll subtract 0.1 one more time, and this is 2.7 times 10 to the negative 17th power. So this is not 0. This is a number that is just, 0.00000, a bunch of zeros, and then 2. This is a number that's slightly above 0. And so we look here, and it says if the velocity is above 0, subtract 0.1 one more time. And so I'll take this number and subtract 0.1 one more time, and you can see that I've now flipped. I would flip my velocity into the negative direction. So this is almost negative 0.1. Okay, and so that explains the reversing effect. And so what that means is we just have to do a little bit of a fix in here. And what I'm going to do is modify my stop horizontal to say, instead of saying if it's less than 0, I'm going to go 0.1, or if it's less than negative 0.1, we will add 0.1. And if it's greater than 0.1, we will subtract 0.1. And then I'll just say else self.vx is equal to 0. And so, right, so, now if my velocity is, like 0.1 or greater, we'll subtract. But once we get down to that, on that final step, when we get down to that number that is potentially slightly below 0.1, but still in the positive direction, rather than try to subtract 0.1 again, hoping we land on 0, we'll just force the issue and make the velocity land on 0. So let's test this out. And we'll go up here. I'll accelerate to the left, and I'll accelerate to the right, and everything seems to work nicely. And so with this approach, I can use any friction component that I would like. So I will leave it up to you to go fix the go up, down, and stop vertical functions. It's really the same thing, except for you're just changing all the VXs to VYs. So I don't think you need to see that in the video. But I will kind of talk about one thing that's going to that we'll fix in the next video, and that is, I'm having one of these magic number problems where I'm seeing this 0.1 occur all over the place, and so really that we're getting into a situation where maybe we should think about having this 0.1 stored as a friction variable somewhere. But I will save that for the next video.